everyone. So today we are going to do a little bit more in this section of notes on 2.3 factored form. So you should all have a copy of this notes packet, and we are actually going to do, if you not scroll, you are not going to scroll because you have it in paper. I'm scrolling. Okay, you're going to go to, on yours, it's the back of the second page, like the second actual paper. You're going to go to this. It's called zero product property. And so this is actually, now we're getting to the meat of like what this whole section is about. This whole section is called factored form, and it's about solving quadratics by factoring. And so what it means to solve a quadratic, it's kind of like when you solve an equation, like a linear equation. If I gave you an equation to solve and you got x equals 5, let's say, you solved the equation. To solve a quadratic equation, it's a similar process where you're finding two x values. Mostly it's usually two x values, but in order to solve it, you can't solve it like a regular equation because it's a quadratic. So what you do instead is you factor it and then you solve it. And so that's why we've been going over factoring for the last few classes, because you need to know how to factor in order to solve by factoring. So right down here I have the steps written out here. And so we're just going to follow those steps. So this is what your equation may look like. You may have terms on both sides of the equal sign. Sometimes everything's on one side, sometimes it's not. I will say, in order to solve by factoring, our first step right here, super important, is everything needs to be on the same side. I wrote it as, make sure your equation is set equal to 0. And so basically ours is set equal to negative 18 in this example. And so if it's not equal to 0, you move everything to one side. So you're going to use algebra to move everything to the same side. Typically you want to move everything to the left side. You want to try to avoid having a negative x squared term. You want to try to keep that positive if possible. So to move this negative 18 to the other side, I'm going to add 18. And so then once you bring everything to one side, you want to rewrite it in standard form. So it looks like this. So this would be x squared minus 9x plus 18 equals 0. And so that's what you want it to look like. Once you get everything to one side and write it in factored form, now you factor it. And so at this point, we've done 3 different types of factoring. We've done factor by GCF. We've done factoring a trinomial when a is 1. That's where you just think about numbers that multiply the last term, add to the middle term. And then we've done factoring where a is bigger than 1, where I taught you grouping and box method. Most of you did box method. So to factor, you kind of have to determine which type you have to do, which is the hardest part. This is a trinomial where a is 1. So you can just think about numbers that multiply to 18 and add to negative 9. So if you don't know, go to your factor chart. Think about the two numbers that would multiply to 18, add to negative 9. Keep in mind they both have to be negative in order to add to negative 9 and multiply to positive 18. So hopefully you thought of negative 6 and negative 3. Those would be the two. So you write it like that. You don't have to do the box. Again, because a is 1 here, a is not bigger than 1. So next, to solve it, here's the new part. So far everything we've done is pretty much the same. Here's the new part. Set each factor. Each factor is each binomial. Like this is one factor, aka binomial. That's the other factor / binomial. So you're going to set each individual one equal to 0 and solve for x. And so the reason why we do that is these two binomials, factors, whatever you want to call them, next to each other are being multiplied, right? When they're just next to each other like this, it means it's this times this. And so this is all equal to 0. And so basically what we're going to do is we're going to figure out what x value would make this binomial 0. Because if this binomial ended up being 0, 0 times whatever this is equal to 0. And vice versa. And so basically we're just trying to figure out what x value would make each of these 0. So that's why we set each one equal to 0. We do this. X minus 6 equals 0. And then you do another equation. You want 2 different equations. X minus 3 equals 0. And then you solve each one for x. So I'm going to add 6 to both sides. So I have x equals 6. That is one of our solutions. And then add 3. X equals 3 is our other solution. So 6 and 3 are known as the solutions. If you remember at the very beginning of this section, I talked about how solutions for a quadratic are also known as zeros or roots or x-intercepts. So if you take a look at this graph right here, 6 and 3 are the solutions, which this graph represents this equation. Notice that 6 and 3 are the x-intercepts. See that? So those are the zeros, you'll hear me refer to as zeros, or the roots, or the solutions. They're all the same. X-intercepts is another way to say it. We'll be talking about zeros all year. Okay, so there's our first example. So your end product, your end answer, you want something like this, 2x values. Okay, let's do a couple more examples. So example 6. I'm going to erase some of this because I made it a little bit messy. Example 6 we have here. This one is already has it where everything is on one side. See how this one is already equal to 0? So we don't have to do any rearranging. This side is already in standard form, which is what we want. So now we can just factor. Notice that this one, a is bigger than 1. A is 3. So typically you would do box method. But remember, I always want you to first look for a GCF. See if there's something that they all are divisible by, which this one does, right? 3, 3, and negative 60 are all divisible by 3. So the GCF here is 3. So I'm going to take out a 3 first, which we should all remember how to do. Take out the GCF. And then now I'm going to look at what's left in the parentheses. See how this has a 1 in the front? So now I just have a regular trinomial where a is 1. So now I can just think of numbers that multiply to negative 20 and add to negative 1. 1 positive, 1 negative. It's going to be negative 5 and 4. Because negative 5 plus 4 is negative 1. Negative 5 times 4 is negative 30. Negative 20. I don't know where I'm getting 30 from. This 3 that we took out has to stay in the front. So that was the GCF. That stays there. Now when we solve by factoring, which we've already factored, so now when we solve it, we have to set each factor equal to 0. So this is going to be equal to 0. And you solve. This is going to be equal to 0. And you solve. So I'm going to add 5. So x equals 5 is one of my solutions. And then I'd subtract 4 here. X equals negative 4 is my other solution. This 3 in the front, we don't have to set equal to 0. You only have to set factors equal to 0 if there's an x in it. So we don't have to worry about that 3. So these are our two solutions right here. So that's example 6. Let's take a look at number 7. So for this one, notice that that 14 is all by itself on the right-hand side. So our first step is to move everything over. So I'm going to move over that negative 14. So we have 2x squared plus 3x minus 14 equals 0. So I have everything to one side. It's in standard form. So now we have to factor. So remember, to factor, you have to look at the leading coefficient. It's a. A is bigger than 1. A is 2 here. So that means we'd have to do box method unless there is a GCF like in the last example, but there's not because there's no number that goes into 2, 3, and negative 14. So instead we have to do box method because a is bigger than 1. So to do box method, or if you did grouping, I think most of you chose box method though. Remember, you multiply the first and the last. So 2 times negative 14 is negative 28. And then from there, we have to think of numbers that multiply to 28 and add to 3. So go through your factors. One's going to be positive, one's going to be negative because we want them to multiply to a negative and add to a positive. It ends up being 7 and negative 4. And so what we're going to do is set up our box, right? So let me move this down. So I'll do it over here. So set up your box. 2 by 2 box, remember. Top left-hand corner of the box is the first term, 2x squared. Bottom right-hand corner of the box is going to be negative 14. And then in the other two spaces, we're going to take 7x and negative 4x. Okay, remember what we do next is we identify the GCF of each column and row. So this column here, 2x squared and negative 4x, the GCF would be 2x. This column here, 7x and negative 14, it would be 7. Now we want to do this row, 2x squared and 7x. The GCF is x. Now this row, negative 4x and negative 14 is 2, goes into both of them. But since this box closest to where I just wrote the 2, this box is negative, so that means my 2 has to be negative. And so then let's write our answer. I'm going to go back to blue. So for our answer, we have, well, not our answer yet, but our factored form is x minus 2 and then 2x plus 7 equals 0. From here, we have to solve, so you have to set each factor equal to 0. So this is going to be equal to 0, and then 2x plus 7, this will be equal to 0. And then you just solve each equation. So I'm going to take x minus 2, and I'm going to add 2 to both sides. So x equals 2 is one solution. Subtract 7 here. So you have 2x equals negative 7, and divide by 2. So x equals negative 7 over 2. You can write it as negative 3.5 if you prefer, or 3.5, negative 3.5, doesn't matter. But those are your two answers for that one. So that's that. That's how you solve by factoring. I'm going to save these last two examples for when I see you in class. Where are they? Oh, well, they're not on here anyway, so that's perfect. Your packet should keep going, and you have example 8 and example 9. If you'd like to try it, go ahead, but we'll probably start with those when I see you tomorrow. And so, yeah, so that's that. I'm going to give you a couple problems to try, and let me know if you have questions, but we will do more of them tomorrow when I see you. All right, have a great day.